And so maybe you could just tell me what the weather's like where you are. And
well, it's sunny on
levels.
Oh, sorry.
So go ahead.
Yeah, it's sunny on Independence Mall. I guess it's in high 60s, and little breeze from the Delaware River. Pretty pleasant weather.
Sounds nice.
Absolutely.
Is it okay with you if we post this full interview to our show blog?
Absolutely, yes. And please do that. And I'll sort of put the link on my website at the college.
Oh, that would be lovely. And
Yeah.
I'll link back to you. And yeah, just, you know, our audience is very smart and interested and engaged, but they're not technical, so we'll have to keep the references fairly simple.
Absolutely. Nora, I have one question before we
Yes.
begin. I'm actually running a small video camera here in studio, so
Oh.
if you don't mind, I can put it on the website too, so it would be your voice, my voice, and my
Sure.
strange face.
That sounds great.
Okay? Yes. Let's be technical.
Okay. Are you ready to go?
Absolutely.
Okay. Hi, Eugene.
Hi, Nora.
So who is Solomon?
Solomon is a second-year-old buck, a male deer, which lives in Pennypack Ecological Restoration Trust, which is technically very close to Philadelphia, and it is partially green area, partially it's a build-up area, so it's suburbia at best.
Okay, so there's part of it is a nature preserve and part of it is just regular neighborhoods?
Correct. It is
okay.
not only nature preserve, it's also effort to restore the biomes which were here about 200 years ago.
Okay, and why did you want Solomon to have a blog?
Well, for many reasons. We were looking to find a system which is totally independent from human input, and it should be also make the data available to all, and in addition, the data should stay there forever. So as it turns out, these deer are in the blogosphere forever.
Okay, and what kind of problem were you trying to solve here? Why did you need to track the deer in the first place?
Well, there are several problems. The project is run by a small liberal arts college called the Green Athens College. And we were looking for a potential project which has management dimension, which has restoration dimension, which has ecological dimension, which involves community, and very, very deep scientific problems. And we found that deer actually can carry very high-tech instruments. They are big enough, they are very abundant species here and very well managed under Pennsylvania Game Commission, and we can actually model a lot of problems which we happen to solve in our ordinary life, you know, how we move, how deer move, how animals move, how everything moves in this planet.
Okay, so what kind of system did you set up so that Solomon can blog?
Well, the system is very simple. First, we actually set up a blog which is actually run by Solomon. It has a collar which has a GPS inside and also a cell phone. And every 40 minutes, it sends to this blog, it has an email address, the set of coordinates, which then I channel through the set of Google spreadsheets, and they display data, latitude, longitude, and time in near real time, so I can actually see where the deer is. And as I wanted to make the system is, it should be set up so that the management can actually see where the deer is, so they won't disturb the wildlife when they do management things like, you know, cutting grass or trees or making trails. And in addition, we actually use the data to model the movement of deer across various habitats in different time of night and day.
Well, I'm relieved to know that Solomon isn't blogging actual words, because that would be scary. So what would I actually look at? What would I see if I actually went to the blog? What does it actually look like?
The blog is actually a set of coordinates, and it says, basically it's a text messaging, SMS messaging system which make a timestamp and latitude, longitude, and various other parameters such as battery life or time to take fix. And the beauty of this system is actually that the Google spreadsheets is something which you cannot really delete. And if you switch off the system in any college, it still survives. and it still will track itself. And in addition, it is actually simple as it is, but it is actually artificial intelligence, which runs on the cloud of computers which run by Google. God knows where they are. It may be in Taiwan, it may be in Canada, it may be in Angola. You don't know, because they actually share time and their calculation capacity across many computer cloud. And we actually make this Google system to construct a Google Earth file for us. It actually maps itself, so it actually streams the data as we speak into the Google Maps. And it also, the blog itself is data indestructible. So we actually get the new quality which we never thought of, because originally when the problem was originally planned and we applied for various grants, we didn't have Google documents at all. Google Earth was in its infancy, and I was planning to do that on SQL Server in sort of very traditional ways. But now we don't need sort of dedicated computers. It's all done in this sphere of computers, constellation around the planet, which brings totally new quality to the whole project. It's not just tracking, it's the wildlife sends the signals for humans to interact via computers. It's
Because the whole thing lives online.
Precisely.
Right.
Precisely. So actually, behavior of deer is actually reflected in behavior of humans. I know where I have to go to in order to see this animal, or I know the area which I should avoid to in order not to disturb this animal. So that is a brilliant way to interact. And it brings, actually, sorry, I just put this point a bit further. There was one theory, one idea that actual sphere of Earth consists of not just lithosphere, atmosphere, or biosphere, but also the noosphere, the sphere of human's brain. Yes. And actually, that is precisely what we did. We actually let the deer to interact with this noosphere. And that is wow. Simple as it is. Yes, simple as it is. But it's just sky's the limit, because Google made all sorts of data available online. We can stream it in. We can overimpose it on this data. We can actually see what deer decides, and we actually make several interesting equations built in this Google spreadsheet, so they can actually predict where this deer location will be.
I mean, can we talk about the possible applications of this? I mean, it sounds to me like you need to be a real whiz, certainly, to think up doing this. But is this something that you could imagine people more generally doing if they had, a thing or other types of movement that they wanted to track?
Well, you see, it's very simple. You basically log latitude and longitude and time. But that is just coordinates, Descartesian or Cartesian coordinates. You can actually track anything. You can actually go to the website, which is named very interestingly Spark Fun Electronics, and buy small, buy small chip, less than $100, which has GPS and SMS card built in, and put it on your car, and track your car, whenever it is, or your boat. So that is doable with very simple home applications. But we wanted to make it more interesting. Coordinates is just a digit. We can model X and Y coordinate. We can actually forecast where the animal might be based on the probabilities of its previous locations. And it could be any digits, like, if you place, say, income on one axis and inflation on the other, and try to plot this cloud of observations which are called the electorate. We can actually see how these parameters can actually make the whole population move. Is it going to be more conservative? Is it going to be more liberal, or where we're going to? And it's not just limited to 2 dimensions. Simple as it is, but since we actually don't employ a computer which sits somewhere on the desk, Google does it for you. It renders somewhere on marginal computer powers. We don't need supercomputer to do simple applications, but because of their forecasting power and their availability to mass public, that's a totally new quality, which I started to realize it's not really properly understood or even sort of realized.
So you're basically using sort of free online tools that are, widely available for anybody, really.
Correct. Yes. Correct. So, sorry. Go ahead.
No, go ahead.
Well, they are not only available to anywhere; they are available worldwide, and no matter what you try to do with that, it's impossible to delete. It renders it regardless where you are, where you try to look at this website. We saw very interesting visitors to our webpage from Thailand or from China, and they were equally intrigued. You actually see the movement of a deer in the wilderness in real time.
Mm-hmm.
And it's just fascinating as it is. It's new language. You can actually see things which were not seen before.
Mm-hmm. Are you concerned at all that people might want to know where Solomon is in order to hunt him?
Very much so. Well, first, there are strict laws to hunt in the built-up areas. So
Okay.
we're pretty safe on that. And, any person with weapon will be immediately treated as a problem by both police and local management. Second, the deer which we actually put on public display is actually in private grounds, so there is no direct access to this grounds. It's a church land, and we have very good relationship to the land management, and occasionally it goes to the Environmental Restoration Trust, which also under strict protection. So we're not concerned, and if we see any slight suggestion that this data are actually used in order to harm the animal, we will immediately treat the problem on personal and computer level. So we just withdraw the stream from the line.
Do you have any other projects in the go?
Yes, similar to that, basically the animals blogging themselves. We have several tundra swans which are currently on North Slope, Alaska. I was very proud to make such spreadsheets which actually filter out positions which are delivered by satellite, so it's basically tracking by satellite. It's another technology. They don't have GPS. And we also have projects in Russian Far East with the stellar sea eagle, which is the largest eagle in the world, and it looks that we're not going to share this data to the general public because it is highly endangered species, and we don't want any harassment by potential photographers or hunters to be navigated by our streaming data. So we use it for internal use only.
Mm-hmm. Yeah, I guess that's one of the big questions about this kind of stuff, just because it is so potentially accessible around the world, is how do you decide what should remain public and what should remain private?
Well, there are several basic rules which we follow. So no data should harm the animal. That's paramount importance. Second, the data which can end up in wrong hands should be delayed in a way. So we can actually make a delay mechanism so any potential hunter wouldn't be able to come to the deer even close. So these tools, but I don't think it's a big problem because the nature of hunt in civilized way is unpredictability, and if you use computer tools to track the animal and use iPhone to come to the animal, which is actually illegal, you have to understand, that brings a lot of moral issues, and they're handled with the current legislation quite efficiently. So I don't think it would be a potential problem. But endangered species, that's a different thing. There are people who actually try to take photographs of endangered or rare species, and there is also illegal trade if we're talking about other countries. So before we put the data on the web, we actually discuss it and take very serious issue of secrecy of the data.
Right. This approach generally is called geoblogging, where blog posts are related to specific locations. What other applications do you see for what you're doing beyond the specifics of tracking animals?
Well, quite a lot actually. Animal movement as such is a very nice model to make various predictions based on position of an object in time and space. So I'm here not because I want to be here, but because I was on point B 5 minutes ago. And this logic can be applied to various applications, which is not really by most advanced Google pioneers. Like imagine, you have a deer which faces shortages of food because it was, 20 centimeters of snow or, and ice crust. and we actually see how the home range changes. There are several modes the deer can go to. It might actually run like crazy in entire home range, or can actually shrink the home range and stay put. We see both modes, and that model is 100% applicable to current traffic. Imagine if the gas prices will increase to the level of $15 a gallon. It will change entire social structure of human settlements. We're talking about drastic structure, and we're going to see these changes. No matter when, but sooner or later we'll have its limited resources. It's very easy to predict what's going to happen. And we will have enough models how to actually make this time and space movements and predict these movements. Second application is incorporation of various Google tools into something more applicable to the travel. You're probably familiar with a lot of web-based services how to find a route, MapQuest or Google Maps or Yahoo Maps. You actually specify point A and point B, and it suggests you a couple of routes to go to. But it doesn't actually have a streamed information from the roads. But you can actually get this information online. You can actually model how many delays it might happen if your travel is going to be planned at 5 p.m. And actually the route can suggest you alternatives. You can stream the weather data. If you actually see the cold frontier which moves T-storms, you can actually make a space model, and which will advise, here is the problem. You'd rather stay here at the service station, take a cup of coffee, and it will mitigate the gas expenditure, and also will keep you out of stress. So, and that is trackable. You can actually stream the data and temperature from the Google instruments along the route anywhere. It's just very simple script. You can do it in Google spreadsheets or in KML files in Google Earth. But I don't know why it hasn't been done. Or post the prices of gas along the route, and let the Google spreadsheets, the small artificial intelligence, to decide what is the optimal price for you in that route to get refueling. And since you can actually stream the past data, and any geoblogging would offer a plethora of past data, you can use it as variables to predict the future. I don't know why it's just limited to the route. You can actually stream live data. Google traffic is first step in this direction, but you can actually model it like a number of accidents in particular stretch of a highway, and actually time it, and actually route it in alternative way to avoid such problems. This information is mostly on the internet. It's shared. It's just a matter of integration, and that gives something new to the quality of understanding of how we move and how we understand it.
It's fascinating stuff, Eugene. Thanks so much for telling us about it, and we'll post a link to Solomon's blog, okay?
Oh, thank you very much, yes, and thanks for having me.
That was great. I just am wondering if we could just return to the, I'd just like to give people, before we get into the larger issues, give people a sort of a clear picture. Like I think from Liz, my understanding was partly it was motivated by wanting to know where the deer, like why you wanted to know where the deer were from the point of view of deer.
Yeah, from deer biology to management.
Yeah.
But you see,
maybe I'll just ask you the question again.
Sure, yes. Well, a traditional way to track animals is you get the information stored somewhere on the server. It could be SQL server somewhere elsewhere, and then you go to your computer and you download the data. You have to be in your office space. You have to use your computer power. You have to use your GIS software to make a map, and then you post it somewhere on the blog. What we actually did was we omitted this stage. You don't need online you don't need express analysis. It's already done by this little spreadsheets which working within the Google system. So from one hand, we actually were interested in deer management and how it is applicable to a small, very confined pennypack ecological restoration trust and very active and busy community surrounding it. So interactions, how people interact with animals, do animals avoid it, and when animals cross the roads, and why. And there could be potential ways to analyze it in traditional way, and we're doing that. we just added something which let us understand the movement on the fly, on real time, and we use it in real-time management, and people who actually work on the ground, every morning they come to their offices to actually check the locations in order to not to disturb our animal, which is marvelous.
So just to be clear then, why was it important to know where the deer were going?
In order to predict its movement, in order to predict how it changes various habitat types, in order to model what kind of vegetation is more susceptible to deer damage and when, and what risk you can actually pose on the roads in particular time of day. So it's just modeling, so it's data accumulation, and we're using traditional methods to process this information. The online data, we actually see a lot of qualities when you actually process it on the fly in real time. And it's a way to interact with animals. They interact with us, we interact with them, and we just put computer in between.
That's great. Thank you very much. I have a couple of really quick housekeeping things. Can you say your name and what you do?
Eugene Potapov, and I'm a wildlife ecologist, ornithologist. I'm doing mostly raptor birds, the raptorial birds such as falcons and eagles. And also I teach at Breen-Athen College, which is a very small but very mighty liberal arts college in northeast Philadelphia.
Great. And can you say your name by itself for the credits?
Eugene, E-U-G-E-N-E, Potapov. Peter, Oscar, Trevor, Alpha, Peter, Oscar, Victor.
That's great. Thank you. And if I had to ask you, if we were riding in an elevator and you had 30 seconds to give me the quick version of what your hack is, what would you say to me?
Well, it's very easy. We actually use absolutely free public servers to use for processing the live movement data of live animal. And it's actually small artificial intelligence which runs not on single server. It actually runs in a constellation of in blogosphere.
Right. And what did it let you do in this particular case?
Actually make local decisions in real time.
Great. Thank you very much, Eugene.
Thank you very much.
Much appreciated.
My pleasure.